Hello again. We are continuing with the gateway problems. We are starting a new section now in problems 31, which is this problem, to 40. We will be looking at the powerful chain rule that tells us how to differentiate a composition of functions, or how to take the derivative of one function inside another. So one fact that we'll use quite frequently throughout is the Leibniz notation. So here we see b in red is a function inside of a, right? So here we say a is composed with b, or b is inside a. So to take the derivative of this composition, the chain rule tells us to first differentiate a with respect to b and multiply that by the derivative of b with respect to x. We'll see how this plays out in later examples, but it's important to keep this general formula in mind. So let's take a look at our specific problem. Here we want to find f prime of x if f of x is given by the cube root of x to the fourth minus 7x. Now, one thing we're going to want to do very frequently in these type of problems, as we've seen in earlier problems, is to rewrite a radical as a fractional exponent. So before I apply this rule, I'm just going to rewrite this cube root as to the 1/3, okay? And then the innermost function is exactly the same. A word of warning, exponents do not distribute, so you should not think to write this as x to the 4/3 minus 7x to the 1/3. That is incorrect. So now what we are going to do is identify this specific problem with the general Leibniz form of the chain rule. So here we write f prime of x, the derivative that we seek. So first what we're going to do is essentially we're going to treat this problem like an onion, like peeling an onion. So we're going to start with the outermost layer or function and work our way inside. Many of the problems in this section will have just two functions composed, but more difficult problems in later sections may have several. So the outermost function here is raising its argument, the inside, to the 1/3. So what we do is we differentiate the function something to the 1/3 with respect to the innermost component. So the way that looks is it's just a straightforward power rule calculation. We take this 1/3, bring it down here, and then 1/3 minus 1 is negative 2/3. So here you can see the structure of the power rule. This is the dA/dB term, and now we will just rewrite the argument inside. So far so good. But the problem is that our innermost function is changing as well. So we must take its derivative into account. So what the chain rule tells us to do next is to take the derivative of this innermost function, x to the fourth minus 7x, and differentiate that with respect to x. So I'm going to put a times sign here. And now we differentiate the inside with respect to x and get 4x cubed minus 7. And this product of two factors is exactly what the chain rule gives us. So at this point we have found the derivative of the original function using the chain rule. Along the way we used our sum difference, constant, multiple, and power rules, which should be very familiar to you by now. And now we're done. There's no need to simplify.